Good evening, good afternoon. Um, this is worksheet number 6 for academic decathlon mathematics section. Solving lots of different equations, linear, nonlinear. So we're going to isolate our variable by getting rid of the addition and subtraction first in this problem. Divide by -4. Those are inverses. X equals +2. If you want to check, you can plug it back in. That gives you -8 plus 9 is 1. We're not going to check. We'll subtract 5. X over 2 equals 4. We'll multiply by 2. X equals 8. That's a horrible 8. 8 divided by 2 is 4 plus 5 is 9. We're going to move our variables first. I always move variables before constants. That gives us 4x plus 2 is greater than or equal to 18 minus 2. 4x is greater than or equal to 16 divided by 4. My solutions are greater than or equal to 4. Didn't say graph, but if we wanted to graph, the graph would look like this. Closed circle because it's equal to, greater than, going to the right. Absolute values first, always have to custom. I'm doing a video. Everything okay? Okay. Sorry, thank you for your patience. Okay. We'll just leave it like that. Absolute values, we always want to isolate first. Sorry about that. Isolate first. We're going to draw, because this distance can either equal 5 or -5. If it was -5, if x minus 3 was equal to -5, the absolute value of -5 would produce this. And if x minus 3 equaled +5, +5 in here would produce a distance of 5. So we'll add 3. X is equal to -2. We'll add 3. X is equal to 8. We write our solutions in solution sets, and we write them in numerical order. Absolute value inequalities, that distance, you write x is less than 8 less than, or less than or equal to, means and, greater than or equal to means or. So this is going to be an and statement, and then we flip the inequality, and we flip the sign of this number. I love it. I asked if everything was okay, and she just liked it. Didn't. She did not tell me that everything was okay. I'm assuming everything was okay. We're going to graph this. X is less than 8. Let's do -8. Let's do 0. Let's do 8. We'll graph this in green. That's an open circle going this way. This blue one is an open circle going this way. This is not the solution. You can't leave it as the solution. You have to rewrite your solution showing where the and requires 2 trues, and or is at least 1 true. So we need 2 trues. Where are there 2 trues? It starts infinitely close at -8 all the way to infinitely close to 8. It is the numbers between -8 and 8, not including them. Equation, again, we're going to write 2 statements. 5 minus x equals 3. and 5 minus x equals negative 3. We'll subtract 5. Negative x equals negative 2. We'll multiply by negative 1. X equals 2. And then minus 5, negative x equals negative 8. Multiplied by negative 1. X equals 8. If we plug in a 2, we get 5 minus 2 is 3. Absolute value of 3 is 3. 5 minus 8 is negative 3. Absolute value of negative 3 is 3. So these two solutions work. We can complete the square, but I wouldn't complete the square because it's odd. I would move it over and isolate, set it equal to 0. Plus 10 equals 0, and then I'd do a times c, a being 1, c being 10. Factors of 10 are 1 and 10, 2 and 5. My signs are the same, they're both positive. This is equal to my middle, so I'm going to use these two values, x squared plus 2x plus 5x plus 10 equals 0. We're going to factor by grouping. Factor out an x, x plus 2, factor out a 5, x plus 2. I know I did it correctly because they are the same. Let's pull out that x plus 2, and that leaves me with x plus 5. That's a bad 5. Equals 0. Let's use the 0 property. One of these must be a 0 because the product of, when we have the product of two numbers equaling 0, one of them must be 0. So the x value that makes that 0 would be negative 2, and the x value that makes this 0 is negative 5. We're going to put them in numerical order, and those are the two solutions to that equation. Let's minus the 2x. We will again move it and set it equal to 0, but this time we're going to factor. We only have two terms, so we can factor out a 3x, leaving us with x minus 4. And this is still the product of two things to make 0. So we get this. We'll divide by 3, and x equals 0. And we'll add 4, and x equals 4. So my solutions are 0 and 4. Those are the two values that solve that equation. We'll move the x over. X squared plus x minus 12 equals 0. We'll do a times c. A is 1, c is negative 12. Whoa, that looked like a 13. I want a 2. Factors of 12 are 1 and 12, 2 and 6, 3 and 4. My signs are different, and the bigger is positive. This is 11, this is 4, this is 1. My middle term is 1. We'll use negative 3 and 4. Minus 3x plus 4x minus 12 equals 0. We'll group. Factor out an x, x minus 3, factor out a 4, x minus 3. We did it correct. X minus 3, we pull it, and we're left with x plus 4. Set them equal to 0. X minus 3 equals 0. X plus 4 equals 0. Add 3. X equals 3 is one solution, minus 4. Negative 4 is the other solution. Negative 4 and 3. Inequalities. I don't know if I've ever seen an inequality. Huh. That's interesting. Wow, that's really bizarre. I don't think I've ever done in all my years. We can still do it. We'll factor this. And so we have my A and my C. A is 6. C is negative 2. Negative 12. 1, 12, 2, 6, 3, 4. Signs are different. Bigger's positive again. This gives me my 1, so 6x squared minus 3x plus 4x minus 2 is greater than 0. That looks like an equal sign. Very sloppy handwriting tonight. Sorry. Group will factor out a 3x. You get 2x minus 1. Factor out a 2. You get 2x minus 1 is greater than 0. These are the same. 2x minus 1. 3x plus 2. Yeah, I mean, I think we still keep going. The same thing. 2x minus 1 is greater than 0. I don't know if this is going to be right. This is going to be interesting, but is greater than 0. Because technically you can have both of those. I don't know. We'll try it. We'll see what it produces. We'll test some solutions and see. It's greater, so it might be an or statement. Is greater than 1/2 minus 2. 3x is greater than negative 2 divided by 3. X is greater than negative 2/3. Okay. Or, I think, I mean, right? I don't know. It's, where is an and? I don't know. Let's do negative 2/3, 0, 1/2. We'll do this in blue. Open circle going that way. We'll do this in green. Open circle going that way. So if it's an, I think it is an or. Yeah, I think it's an or. So I think my solutions, I think the solution is going to be this. Negative 2/3. Open circle going this way. What number is this? This is number 10. So let's see. Solution for 10. Now, less than negative 2/3, greater than. So, I think what my assumptions were. So, why do we flip one and not the other? Well, I was thinking 2 negatives and 2 positives, right? Because that's how you can get a value greater than 0. Let's look. Let's take a peek. Let's see what we can find. How do you solve quadratic inequalities? Let's see. Yeah, we use the boundary points, number line, create intervals. Yep. Video, solve. So we get those. Right, okay. Okay, rewrite the inequality. Got it. Set the quad 0, did that. Solve. Plot the roots on a number line. These roots divide the number line into intervals. Test a point in each interval. Choose one test value from each interval. Substitute each test value into the original equality to see if it is true or false. You can watch the video. The intervals for which test value makes inequalities true are the solution set if the inequalities include boundary points. Okay, so let's try that. Very cool. All right, so these are the boundaries. So I think, these are the boundaries, and let's test inside there. So, so we don't know. Well, let's take these colors away. No, we can just take that away. Let's take that away. Take that away. All right, so if we, let's take that color away. So let's take a point from this area, test 1. So that would be -1. Let's do -1. Excuse me, sorry. Let's not do it in green because green looks like we know that it's So let's test negative 1. So if we plug negative 1 in here, negative 1 gives us 1. So that gives us 6 minus 1 minus 2. That's greater than, so that's true. So that ended up being true. Let's pick a number in here. In this boundary, let's take negative 1/2. Let's test that. So negative 1/2 gives us, let's do, negative 1/2. So negative 1/2 gives us 1/4, gives us 3/2. Negative 1/2. That's going to give us 1/4. That's going to give us 3/2 here. 3/2, good, which gives us 1. Which gives us 1 minus 2 is negative 1. Negative 1 is not, so that area is false. Let's pick a number between 0 and 1/2. Let's take 1/4. Let's test that. So 1/4. 1/4 gives us 1/16 times 6 gives us 3/8. 3/8. 3/8. This is 1/4. So that's 2/8. So that's 5/8. And minus 2 is going to be a negative number, which is not greater. So that is false. This is false. And let's try 1. Let's test 1. So 6 times 1 plus 1 minus 2 is going to be greater than 0. So that's going to be true. So yes, we don't put these inequalities in yet. We just found the boundaries. All right, so, that works. X is less than negative 2/3, and X is greater than 1/2. Very cool. Okay, I like that. That's pretty nifty. Didn't know that. Learn something new every day. Solve the systems of equations, so we can substitute it in and solve it. And we can use the substitution. We can do the addition, subtraction. We could also graph both of these. That was the cool thing. So let me show you this if you get Desmos. Desmos. Here's a neat technique of showing. So you have y equals, what was my equation? 2x plus 1. So you have y equals 2x plus 1, and then you have y equals the absolute value of x minus 3 plus 2 plus 2. And where they intersect is your solution for your x value and your y value. So it is 1 1/3, 3 2/3. 1 1/3. So, whoopsies. Wow. What? Delete. Let's move this. Let's take this. We'll copy it. So this is a nice, fun, cool way of solving these. Let's make it smaller. And let's put it over here. And so we think that we see that our solution is going to be, why do I keep going green? I don't want green. Our solution is 1 1/3, comma, 3 2/3, or that is 4/3, comma, 11/3. If we substitute, using the substitution, we would get, let's substitute this in for y. So we'll substitute it in for y there. So you get 2x plus 1 equals the absolute value of x minus 3 plus 2. And we can minus 2. We get 2x plus, no, minus 1. 2x minus 1 equals the absolute value of x minus 3. Actually, let's reverse that. Absolute value of x minus 3 equals 2x minus 1. We write our two statements. X minus 3 equals 2x minus 1. And x minus 3 equals the opposite of 2x minus 1. So let's move the variables. Let's move the constants. You get negative 2 equals x. That doesn't work. That's very interesting. Oh, did I miss a point? I think I missed a point. I forgot that it'll intersect somewhere else up there. No, those don't intersect. No, it's just one point. Okay. Let me see. I get x equals 2. Let's do this. X minus 3, negative 2x plus 1. Move the variables. Move the constant. You get 3x equals 4, right? 3x. Divide by 3. Yeah, 4/3. X equals 4/3. So maybe one of them is an exclusion. Maybe this is an exclusion. Yes, let's check it out. So now we take it, we plug it back into one of the original. Let's use y equals 2x plus 1. Y equals 2x plus 1. Y equals 2x plus 1. Let's plug this one in here. Y equals 2 times negative 2 plus 1. Y equals negative 4 plus 1. Y equals negative 3. So that would be a point, negative 2, negative 3. Let's plug in our 4/3. 4/3 plus 1 gives you 8/3 plus 1. Gives you 8/3 plus 3/3, which is 11/3. And that would give us 4/3, 11/3. So these are my two solutions. Why does negative 2, negative 3 not work? So let's do negative 2. Negative 2 gives us, so that would be an exclusion, because if we plug that in, negative 2 gives negative 5. Absolute value of negative 5 is 5. 5 plus 2 is 7. Does not equal negative 3. So this is an exclusion. And this is my only answer. All right, that worked. We can do the same thing. Let's do it. Let's take this, set it equal to each other. Well, we'll just plug it in there. So you get the absolute value of x plus 2 minus 1 equals 3x plus 5. Let's add the 1 over, because we always have to isolate first. The absolute value of x plus 2 equals 3x plus 6. Let's write our two statements. X plus 2 equals 3x plus 6. And the other one is going to be x plus 2 equals the opposite of the quantity 3x plus 6. Let's minus the x. Let's minus the 6. Negative 4 equals 2x. Divide by 2. Negative 2 equals my x value. X plus 2 equals negative 3x minus 6. Let's add 3x. Let's subtract 2. We get 4x equals negative 8. Divide by 4. And we get x equals negative 2 again. That's good. We can plug it back in. Let's do 3x plus 5. Y equals 3x plus 5. Plugging in negative 2. Y equals negative 6 plus 5. Y equals negative 1. So my coordinate is negative 2. My coordinate is negative 2, negative 1. Negative 2, negative 1. Negative 2, negative 1. That's correct. Negative 2, negative 1. That works. So that is the solution. That worked. Let's plug it in again, set it equal. Let's take this, put it over there. 2x equals x squared minus 5x plus 6. Set it equal to 0. That wasn't any better. Set it equal to 0 by moving it. 0 equals x squared minus 7x plus 6. If you're really good, you should know that x minus 1, x minus 6 would give you factors. Multiplied, make this. Inside, outside, make that. And then your solutions are going to be x equal 1 and 6. And then you have to put the x value in. And these are not the solutions. They're the solutions for the x, but now you have to calculate the y. So plug in 1, you get 2. Plug in 6, you get 12. And those are the two solutions. That's pretty fast, right? Same thing. X plus 3 equals x squared plus x minus 6 minus x minus 3. 0 equals x squared minus 9. This is the difference of squares. Two terms, subtraction, both are perfect squares. You get conjugates. So my solutions for my x's are going to be negative 3 and 3. Let's plug them in. That gives you 0. That gives you 6. And those are your solutions. That's how fast you can do those problems. That's the cool thing. That's it. Let's check. Negative 3, 3, 6. 1, 2, 6, 12. 1, 2, 6, 12. 1, 2, 6, 12. Yep, one solution there and one solution there. Cool. All right, that was pretty good. That was a really fun one. That's a neat one to sort of remember and learn it and know how to deal with it. Have a good one.